So this video is about the method we use to locate objects in the night sky. And we're going to look specifically at the celestial sphere, Right Ascension, and Declination. And the celestial equator. Now, the way that we navigate around the night sky is to imagine that all of the stars that you can see in the night sky are somehow imprinted upon some giant sphere that surrounds the Earth. So if this is the Earth here, then we imagine the Earth is encompassed in a giant sphere where all of the stars appear to be projected onto this sphere, and then we navigate our way around the sphere. So first things first is that if we have North and South Pole and the equator on the Earth, we can imagine that if the equator is projected outwards onto this celestial sphere, as we call it, then the equator would appear like that on the sphere. So this big sphere here is called the celestial sphere, and on it we imagine that all the stars are projected. This line here is the celestial equator, and it's the projection outwards of the Earth's equator onto this imaginary sphere. And the way that we navigate around is very much like longitude and latitude. We need to work out how far up we're going above the celestial sphere, or how far below the celestial sphere, and then also how far around the celestial sphere. So if we take an object which is, let's say, here in the night sky, then what we're looking for is how far is it up the celestial sphere. At the very top here we have the pole star, or Polaris, and that would be at 90 degrees, and we call this vertical angle above the celestial sphere, we call that the declination. So the declination is the angle above or below the celestial equator. If it's on the celestial equator, then it would have a declination of 0. If it was directly above our North Pole, then it would have a declination of 90 degrees. Normally positive for above and negative for below. So something directly below the South Pole would have a declination of minus 90. On the celestial equator, it'd have a declination of 0 degrees. Now, the right ascension is essentially how far left or right we go a bit on the celestial sphere. Now, the 0 point on the celestial sphere it's quite a complex idea, and it's very much dumbed down for this course. So what we call is the vernal equinox point, which I won't go into any more detail about. If you want to do that, you can look at my astronomy videos. But essentially, the vernal equinox point is our 0 point, a bit like we have Greenwich, the Greenwich meridian going down through 0 on the Earth. You can imagine this equinox point. Let's imagine the equinox point is here. And that way, if we want to find the position of this, we need to work out what's the angle around, and then what's the angle up. So the angle around, how far we are around, is known as the right ascension. So right ascension is effectively your how far left or right, and the declination is how high it is. Now, in the OCR specification, we don't see any more detail asked than that, so you're not expected to be able to locate stars using those things, just to be aware of them. So, celestial sphere, this imaginary sphere that surrounds the Earth, upon which all of the stars appear to be imprinted. The celestial equator, which is essentially our equator from the Earth mapped outwards onto this sphere. The declination is the height above or below the celestial equator, and the right ascension is how far left or right from a fixed point, which is the vernal equinox.